Hello and welcome. Thank you to everyone for tuning in to our recorded webinar. We're going to be talking about building a resilient system, how Wistia ensured observability in their data pipelines into Salesforce. My name is Donny Flynn. I'm a customer data architect at Census. Prior to working at Census, I led a data team at a company called Cheaper, which was 12 data engineers, data scientists, and data analysts. And with me is Chris Bertrand from Wistia, and I'll kick it over to you.
Chris, I'm a data scientist at Wistia. For those of you who don't know, Wistia is a video hosting and creation platform focused on marketing use cases.
Awesome. We're going to talk a little bit more about Wistia in a little bit, but I'm going to give a quick intro into what Census is. So Census is a reverse ETL tool, and what we enable is operational analytics. When we think about the modern data stack and where data lives in an organization, we view it as a hub and spoke. So here you can see that Snowflake with the data warehouse as the single source of truth for a business. You have a spoke in from different applications and SaaS tools. You have transformations happening within the data warehouse with tools like dbt, and then you have that data being consumed by BI tools like Looker. You also might have like event ingest that comes in from Segment that can also write into your data warehouse. When we think about this model and this stack, this is more of the buy versus build case in which they're mostly point and click integrations, where services are taking care of a lot of that data flow, as well as like the actual transformation. However, Census also is interoperable with the data pipeline ecosystem that you have. Whether you have like an event streaming solution like Snowplow, Kafka, or Fivetran coming at capturing events, taking that into the data hub and then having jobs orchestrated by Airflow, Prefect, or Dagster. The key point of this is that of the Census view on the data world is that there's the hub and spoke model. And what is super important to us is the fact that we have an API that can be triggered from any workflow that you have in any language. Python obviously is one that is very common in the data transformation space for ETL pipelines. And we are contributors to Airflow in terms of having our own Airflow provider for Census, as well as having a task with some open source Python code within the Prefect environment as well. And definitely
we've used that, Donny.
That's right. I'm happy that you were able to leverage that in implementing Census at Wistia. We'll get to that in a second. So thanks for jumping in there. Awesome. As we think about data engineers, especially more of the data engineers that are dealing with pipelines that look like this, observability is top of mind in terms of what data pipelines need to interact with. All of those things on the left that I'm sure that I'm personally familiar with, besides like obviously that last one, pushing buggy code, because I follow the data ops practices.
No one ever does that.
Never pushed a change right to main without testing. But in all seriousness, things fail in data pipelines because of all of those issues that you have to that could come up in terms of data volumes, and that's not even mentioning data quality. That also is absolutely a common cause of failures as well. So if you are already dealing with that in terms of your data pipelines, in terms of the ETL piece, when you add on reverse ETL, while it seems like that should be something that fits easily into that in terms of something that you can just layer on, it actually will deal with record level failures, APIs that behave differently for different tools, as well as different nuances in terms of the actual data schema that you need to send, and plenty of rate limits, and just different API quirks that these different services have. So in terms of, if you're already building your data pipeline, what the Census pitch is to allow us to take care of dealing with these different third-party APIs so that you can focus on your data pipelines and building SLAs with your business owners, thinking about how to optimize your pipelines, and think about how to build out your data definition catalog for your business users, rather than struggle with understanding the HubSpot API, or implementing exponential backoff for iterable. So that's the observability piece. Something that's also super important in terms of the Census view of the world is showing at a record level within the tool what failed and why it failed. So many destination APIs, Salesforce comes to mind, will say exactly the reason why a record failed to be imported into their tool, and often that is very helpful information for debugging, or for different data quality management that you can do upstream. So in order to lower the time that a data engineer needs to spend playing data detective, that's a value add that we want to add to this ecosystem. Goes hand in hand with observability, but it's alerting. How are you alerted when something goes wrong? It's a delicate balance of avoiding silent failures, but also to be disrupted when something is important is actually broken. Just to share an anecdote, our Airflow pipeline would always succeed on the second run, but that first failure would always trigger an email alert. So I would get that first failure, and then I would basically ignore the Airflow errors that would come into my inbox, because I knew that it would recover on that second run. However, with that, in terms of being disrupted when something actually is broken, when something would break, I wouldn't actually pay the attention to it that I needed to in terms of actually playing data detective and going and fixing what actually was the underlying issue in the pipeline. So this problem of how you're paged when something fails, especially as your organization is developing new processes and adding new definitions and requirements in terms of the data pipelines, that's a very important piece that that Census will take care for you in terms of the building out a new integration, so that you don't have to implement a new alerting system for every new tool that you might want to add on and get data out of your data hub into these SaaS tools. So signal is much greater than noise in the Census view of the world. So if a pipeline fails, and those thresholds you can set at the connection level. So when a connection might fail, or a sync just fully fails, versus at the record level. So being able to specify what percentage of rejected records by that destination API you are okay with versus when you would like to be alerted. And on that first failure, Census will send an email or send a Slack alert to you, and then it will also send one alert after it recovers. But so we will only send information that something is failing when it's very important that you hop into the UI, or understand what could possibly be causing this. And the hope there is that you can sleep easy, like the second Donald Duck here, having faith in your alerting system of your data pipelines, rather than having to wake up at 4 a.m. to make sure that your ETL job ran. So with that, I'd like to kick it over to Chris, who's going to talk a little bit about how Wistia has leveraged this in his implementation.
Yeah, great. Thanks, Donny. So I would like to start by talking about what the Wistia data architecture looked like as we were starting to look for options because we were having a lot of issues with it. So that is the Wistia data architecture before Census, hence BC there in the title. So in this diagram on the left, we have users of the Wistia app, desktop and mobile, are interacting with our app. The app is a Rails application that sits on top of a MariaDB database. And our sales team and our success team use Salesforce. And it's really critical for them to have access to information from the main application about how people are using the application for their jobs. And so we had built this custom integration from the Rails app into Salesforce that was making API calls and pushing information into Salesforce. At the same time, we were using Fivetran to replicate the MariaDB instance into our data warehouse, which was Amazon Redshift and is Amazon Redshift. So I want to call out here that this is a very simplified diagram, and I'm actually using Fivetran in a number of different ways. There is actually a Fivetran arrow between Salesforce and our Redshift instance as well. And we're basically pulling in data from all our SaaS tools into the warehouse and from some other databases and from some event streams using Fivetran. So heavily invested in Fivetran. All right, so that's the framing of what the architecture looked like previously. And now I want to talk about some of the motivators for why we were looking to make a change to this architecture and that kind of led us to Census. So prior to Census, Wistia app had this custom integration with Salesforce. There were 5 main issues with that setup that were pain points for us that I'm going to articulate here. So one is that changes required an app level code review. So the events were coming from our main application, and you want to make sure you don't take down the main application with what you're working on. And so that means that you have to pass all of the tests in the continuous integration process, and you have to get a code review from somebody who owns that portion of the application. And it's just a lot of hoops that you need to jump through for what, in essence, should be a relatively small change, right? So if you need to make a change to the data being pushed to Salesforce and you want to sync one additional piece of information, it felt like it was an outsized effort to make that change for kind of the amount of additional data that you were syncing over. Also, as a part of having the integration with the main app, making those changes required working with Ruby, which is the Rails code bases in Ruby. And a lot of the data people at Wistia are more familiar with SQL and Python. And so that really constrained the number of people who were able to make those updates. And the consequences of those two kind of types of friction to making changes was that I don't think we were being as kind of collegially as we could have been with the sales team in terms of making, there was a lot of friction to make those updates. And so we didn't want to make the updates to the synced data that would have been helpful for the sales team. You kind of put off doing those requests that are coming in to the team. And so then another issue was that we only had access to application data. So we use a number of different SaaS tools that don't have third-party integrations with Salesforce directly. And so, for instance, our customer support tool, we would really like to have information about how many times someone has reached out to our customer support team in Salesforce when we're having those calls with sales, when we're having those calls with success. And we were not able to do that because that data didn't live in the application, and we didn't have any way of integrating it into Salesforce. This fourth,
Yeah, no, just a quick point on that. Like in terms of talking about like we've talked a lot about the hub and spoke model as if like that is like the view on the world. There's obviously the point to point model as well, right? So like from the point to point integrations, which is like part of the reason why this was such a need at Wistia was that like the point, the one edge that was going into Salesforce wasn't connected to Redshift. It was connected just to the application database.
Exactly. This fourth one I've listed as an issue here. It's probably more of a requirement, and that's that we have mapped our application data model into Salesforce using custom objects. And to maintain the data integrity of our internal data model, we needed to be able to pass information into Salesforce in a particular way, in a kind of a very set sequence of events. And so that was one of the reasons initially why we had home rolled the integration was that requirement, and not feeling like we were going to be able to meet that requirement other ways. And then finally, in terms of observability, all of our failures got to what I am describing here as our garbage fire of a bug snag instance. So just a ton of noise there, and a lot of over alerting in that instance. And the consequence of that for us is that we weren't able to be proactive in dealing with issues with the integration. We were really being more reactive. So somebody on the sales team would say, oh, this doesn't look quite right, or this information isn't in there and I think it should be. And that means we'd have to dig through the pile of errors in Bugsnag and say, oh, okay. And then you look through the stack traits and you finally find the error, and then you're able to make the update. That's not really a good position to be in. You really want to be in a place where you know about the error before the end user does, and you're able to kind of fix it before it has an impact on somebody else's day.
Yeah,
So,
that makes a lot of sense. In order to be proactive with those kinds of changes, and to be on top of it, so that you're able to keep your stakeholders, your end users happy.
yeah, yeah, exactly. So now I would like to talk about where we are currently and some of the benefits we've derived from the move to Census. And to frame that, I'm just going to look at that same subsection of our data ecosystem and talk about what it looks like now. So no longer are we sending events from Rails into Salesforce. I'm very happy about that. Instead, Census is managing the syncing of data from our Redshift warehouse into Salesforce. On the previous slide, I had mentioned that we have these custom objects in Salesforce that we had to update in a particular sequence. And so one of the deal makers for us with Census was that we were able to do that. And so we're actually leveraging the Census API via this little Python script figure here in the diagram. And so that's how we're using Census, is we're actually running Census exclusively from the API, which has been very helpful for us. So this is where we're at today. And I'd just like to summarize kind of how each of those issues has been improved upon for us. So the data that we're passing into Salesforce from our data warehouse is described by DBT models, managed by DBT models, which is great for us too. And that means that to make a change, you just have to submit a pull request in our DBT repo, which is much better than having to submit a pull request in our main application repo in terms about like friction of the process. And then we have DBT tests on those models that have to pass, and those tests are much faster to run than kind of the extensive testing we do for our main application. To this point as well, I'll point out that the kind of engineering owners for us of the portion of the application where the custom integration lived didn't necessarily have the business context for the changes that we were making in Salesforce. So there's kind of this disconnect where you're making a change to the application code, and then you have to ask somebody who doesn't have the context on why you're making that change to review that. And so that was also kind of one of the pain points of that previous process. Down to the second point. Oh, go ahead, Donny.
No, yeah, sorry. And that just hits again to like that central source of truth for definitions. Like when that's in the data warehouse, like with DBT, that understand like the stakeholders or the salespeople or the customer success. That's a lot different than maybe possibly the engineering perspective on the same problem.
Exactly. To the second point here, so now the changes only require working with SQL, which opens up making changes to the data that's being synced to a lot of other people within the organization, which is great for us. So that should make it much more enjoyable to make the updates to the data that's being synced that are being asked of us. Huge benefit here is on point number 3 of having access to all of the data in our data warehouse. Like I said, we're using Fivetran extensively. And so that means we have this whole slew of data that we're now able to push into Salesforce. So, yep. So a lot of things like our derived business logic live in Redshift in these DBT models. And previously, to get that same information into Salesforce with a custom integration, we were really confronted with whether or not we wanted to build out that business logic into the Rails application, even though it had nothing to do with the operation of the main application, just so that we could get that data into Salesforce. And that's not like a very efficient way to engineer systems. And so that was not very appealing for us as well. So the requirement I talked about of having our custom objects, data integrity maintained in Salesforce, we've been able to achieve that with Census, kind of harkening back to Donny's point about interoperability. We are using the API heavily to run all of our syncs, and we're able to sequence the syncs in exactly the way that we want to and make sure that when new records are inserted into Salesforce or updated in Salesforce, that those updates are happening in a way that all of the data is where it should be.
That's great.
For the final point, the failures now trigger excellent email alerts to let us know what's happening there. With details of all the errors, is able to just comb through the records and see what's going on. And then another facet of this, because we're using the API, when we make those API calls, it's very easy for us to pull back all the information about those syncs. So, how many records failed, how many records succeeded, how many records did Census try to sync, and we're able to take that information and we're able to plug it into our own internal monitoring systems, which is very powerful for us. Just being able to work in the place that we're used to working. Again, I think that's probably goes back to Donny's point about interoperability coming from the API.
Yeah, absolutely. Like not having to change your workflow or where you're living in terms of operational analytics. That's like not having a salesperson have to learn SQL to get the information that they need, and then like to be in 3 different apps, but to have all of that at their fingertips. It's the same for data engineers and data scientists, being able to have the flexibility like via an API, via protocols, just to get that census information in that window into your pipelines.
Yeah. Yes. If you pop back to the last slide, I'll do a little postscript here. So for Salesforce, we just rolled out Census to our Salesforce production instance a couple weeks ago. It's going very smoothly so far, which is exactly what you want. If you're replacing a legacy system with a new system, you want people not to notice. And then once you have the new system in place, you can start to leverage that new system to build out new functionality that's going to be valuable to the end users. I'll note here too that this diagram, and actually the before Census diagram that we had here, this looks right now like a lot like how we're updating information in our marketing automation platform, which is HubSpot. So HubSpot is still in the before Census times, and we're going to take all of the learnings we got from rolling out to Salesforce and use those, I think, to very quickly roll out to HubSpot, which I'm excited about. That brings up another point in my mind, which is that the custom integration to HubSpot that we have from the app was built by different engineers at different periods of time than the custom integration to Salesforce. And so what that means is that the data being sent to HubSpot and the data being sent to Salesforce are slightly different sets of data and maybe have slightly different definitions for certain things. And so that means that there's some inconsistent data between those sources, which is never good, leads to problems, leads to people not having confidence in the data sources. And so that's another thing that we're looking to leverage with Census is when you have a hub and spoke model, you have this single source of truth. And if you have the same DBT models backing the sync to Salesforce that you have backing the sync to HubSpot, you can be totally confident that that the information in those two sources is going to match, which we're really excited about that too. So that's kind of the postscript of where we are now and where we think we're going shortly, hopefully.
Awesome, Chris. Well, thank you so much for walking us through that. Super excited to have this fully be live in your Salesforce and in your data pipelines at Wistia. thank you to everyone who tuned in and listened. If you would like to learn more, if you'd like to chat about anything that we brought up in this presentation, please join us at the Census booth. And a huge shout out to Wistia, and a huge shout out to Chris for helping with this presentation.
Yeah, my pleasure. We're very big Census fans, so my pleasure.
Well, thank you so much.
Yeah.